Multiview drawings can be used to represent three-dimensional objects using two-dimensional views. For example, this part, shown in its three-dimensional form, can be represented by multiple orthographic projections of the part. This is important even in the modern area of three-dimensional CAD programs because it's very difficult to attach dimensions and manufacturing specifications to a three-dimensional view of the drawing. Here, the example part has been created in a three-dimensional CAD software to help us visualize the different views. The three-dimensional drawing with the dimensions on it has been posted on Blackboard. You can refer to this throughout this video to understand the dimensions of the part that we're working on. The first view we'll work on is the front view. We have chosen this side as the front view for this part. You'll also notice that the front is labeled here in the view control. If we were to look at this part from the front, these are the lines that we would see. For the orthographic projection, these are the lines that we draw, and we use object lines to draw them. This has already been done in AutoCAD. Now let's consider the right side view. The right side view is what we would see if we were looking at the right side of the part. In the multi-view drawing, the right side view will be drawn to the right of the front view. To visualize the right view, this is what we should see. Note that orientation is important. If we were to look at the front view of the drawing, the correct orientation for the right side view is what we would see if we took the front view and rotated the part 90 degrees to be looking at the right side. As we go to draw this in AutoCAD, alignment of the views is very, very important. It's critical that the right side view and all of the features in the right side view are aligned with the views in the front view. There's a couple of ways to do that. One way is to simply draw a horizontal line and then start drawing your right side view from this point. Then delete the connecting line, and we have our right side object lines. Again, note that all edges, all features of the part are perfectly aligned. With the right side view, though, there's a little bit more to the story than just object lines. With the right side view, we'll actually have hidden lines. You can think of hidden lines as what you would see if you had X-ray vision. The hidden lines in the right side view will indicate the location of this hole. To illustrate that, I'm going to turn on hidden edges, and notice that now we have dashed lines as if we can see into and through the part. Note if we look at the right side view now, we see hidden lines, dashed lines, showing the location of the hole. Also notice that the other edges, the other hidden lines, for example, the back corner of the part, we don't see those. They're still there, however, the object line is covering it up. When we're talking about orthographic drawing, line precedence always is the object line. So if two lines overlap, the object line always wins. So to create this view in AutoCAD, we will switch to the hidden layer. That will allow us to draw a hidden line. I will take advantage of the fact that I know this hole is midway between these two lines. So I will draw a line that represents the center of the hole. I know the hole has a diameter of 0.5, so I'll offset 0.25 and offset this line either side of the original. And then delete the middle line. Now we have our right side view. Next we'll do the top view. Again, the orientation is important. So starting with the front view, the top view is what we would see if we rotated the part 90 degrees in this direction. Again, note in this view we have hidden lines indicating the hole. On the orthographic drawing, the top view goes above the front view. And again, orientation and alignment of all features is critical. To draw the top view, I'm going to show a different method. I'm going to offset these two lines. And then I'm going to use those lines to base my top view drawing. Switch back to the object layer so we get object lines. And I offset it a little bit too far, so we can move it back a little bit closer. Notice I'm using the move command, and I have my ortho mode on, so I can be assured that I'm moving exactly in the vertical. I'm not going to ruin my alignment with this move. There we have the object lines. Now we'll switch to the hidden layer to draw the hidden lines. I'll show a different method for creating those hidden lines and making sure at the same time that they are aligned. I can simply draw a hidden line from the quadrants of my hole on the front view and then use trim to get rid of the part of the line that I don't need. Now we have our top view. The front, right, and top views are usually sufficient for most drawings. This is called third angle projection. However, these are not the only views that we can make. We can also create bottom, left, and backside views. These have been drawn already in AutoCAD. And this is also available as a printout or PDF that you can print out and fold to create the part as a visual aid. Covering the views quickly, the bottom view again would be, we start with the front view, and what would the part look like if we rotated 90 degrees to look at the bottom. Note now we have additional hidden lines. not only from the bottom do we see the hidden lines for the whole, but we also see hidden lines for this feature and hidden lines for this feature. And this has been drawn in AutoCAD and labeled the bottom view. Moving to the left side, again, we start with the front view. What would the part look like if we rotated 90 degrees to the left? Again, we see hidden lines for the cutout feature and hidden lines for the hole. This is drawn in AutoCAD here. The bottom view always goes below the front view, again aligned, all features aligned. The left view goes to the left of the front view. Finally, the back view, if we go to our left view, as shown before, and then rotate the part one more time, 90 degrees, to look at the back, this is what we would see. Note from the back, the hole is now an object line, but the cutout features are now hidden lines. The back view is shown here. Again, must be emphasized that all of these views must be aligned. Note, for example, that if I draw a horizontal line from the quadrant of the hole that intersects with the hidden line here, the quadrant of the hole here, and the edge of the hole here. That must be true for all features. Now that we have all views of our drawing done, let's add some center lines. Go to the center line layer, and let's draw center lines through the center of this hole. It's important to note that center lines are never required. You add center lines when you feel like their presence will make your drawing easier to understand and easier to interpret. Never forget that drawing is a communication exercise. Just like with writing a paragraph or a description of something, you want to choose words, you want to choose phrases, you want to choose sentence structures that make it easy for your reader to understand your point. Same way with drawings. You want to use features, you want to add center lines when you think it's going to make it easier for your reader to understand what you're trying to communicate. We have a couple of problems with these center lines if I've drawn them. Number one, they look like solid lines. A center line should have a distinct long, short dash pattern. And also the center line should never end right at the boundary of the object. So to take care of that second problem, we will click on the line and we'll use the grips feature in AutoCAD. Notice when I click on that object, AutoCAD allows me to grip center points and endpoints. If I click on that grip and then I move my mouse, I can actually extend or stretch that object. So let's stretch that object by 0.125 inches and do the same thing on the other side. There, we solved one of our problems. But we still don't have the distinctive center line pattern. And the problem here is that our lines are too short for the scale we're drawing at, for it to actually see those lines. So I'm going to introduce a command called LT scale. Simply type LT-SCALE and press enter. And note that we're currently drawing at a LT scale of 0.5. If we make that scale smaller, let's say 0.25, notice what happens to our center lines. Also notice what happened to our hidden line. They become finer. If I type LT scale again, and this time let's change it to 0.75, notice what has happened to our hidden line over here. It's gotten coarser. Let's go ahead and change the LT scale back to 0.25. We can also draw center lines through our other side views, right top view and right view. And now that we've done that much, we can actually use the copy command. Copy this line, for instance. We'll grab the intersection. This is a case where I want the intersection, but I keep getting perpendicular. No problem. We could just turn perpendicular off. Choose this point as the base point, and then I can paste it here, here. Likewise, that vertical line, we can make a copy and paste it here and here. Now we have a complete multi-view drawing of our example part.